Okay, so this video is going to be about energy level diagrams for changes of state. Okay, so all it is a diagram just to show the different phases and the change of state, but it's linking it to exothermic and endothermic reactions. Okay, so exothermic is going to give energy out to the surroundings, where endothermic is going to take in the energy. So we're going to look at endothermic first, okay, and I'm going to build a level diagram. So if we see here, we've got 0 at the bottom, we've got energy. So I could try and just quickly put, that's not going to work, there we go. And now, so energy is increasing, and then this is the progress of the reaction taking place. Okay, so I'll take that off. Now I've kind of, with this here, so the first part, we've got our ice. Okay, so the ice contains an X amount of energy. Okay, so that's where we need to look at it. Now, this process, with it being an endothermic reaction, we've got ice. Now, we can say this is melting. Okay, so we're going to melt. I'm going to try and pull that down there. We're going to melt the ice. Okay, so if I'm going to melt the ice, we get, and that didn't work as I would have liked. So, selection tool, grab that as a complete object. Okay, so it's going to increase, and then from that point it will obviously level out. So what we can say is here, let's pull this up, we've got our ice. Another way to say that, if it's, if we're talking about states of matter, well, that would be a solid, and then it's going to melt. So when we talk about it being an endothermic reaction, the ice is taking the energy from the surroundings, and because it's taking that energy from the surroundings, it's going to melt, and we get our liquid there. Okay, so that's melting. So that's an example of an endothermic reaction using an energy level diagram. It's called level because you've got different levels. So click out of that. Now we can also, so I've also said, we said it was an endothermic reaction. So that's one other thing we can add to that. Okay, we could also say, you could do the same diagram, but just show it as liquid and gas, and another endothermic reaction would be boiling. Okay. So, and then here, finally, for this diagram, incomplete, we will say energy is transferred from the surroundings to the melting ice. So that's a video on the endothermic. Now, if we push on to this one here, okay, so we start off, so we're talking about an exothermic reaction, so I can pull that down there, so it's the opposite, and we're going to go in the opposite direction. Okay, so we're going to have our liquid, and the liquid we could put how much energy to start with there. Now the energy is going to be given out, so it's going to lose energy. Okay, so what we've got here, just to be clear, is our liquid, and it's going to give out energy, and it's going to give the energy out to the surroundings. So hopefully that will pop into there. And what happens is when the liquid gives out the energy to the surroundings, you're going to get a restructure, and it's going to create a solid. So therefore, we're going to get ice. Okay, and liquid to ice is obviously, we're going to call that freezing. Okay, so that would be our process. Okay, so I'm going to put that underneath so I'm consistent, and we're pretty much there. Okay, so we can say, so I've got another note here. So the energy is transferred to the surroundings from the freezing water. Okay, from the freezing water. And so just one last thing. So obviously, if you're going from a liquid to ice and if you go from a gas to a liquid, I think another example would be, if it let me pull it down and it's not, that should work if I do. Sorry folks, not using this technology like, so let's pull that. Right, so condensing would be there. I'm not too sure why that won't let me pull it down. It should just. I think I'm on a losing battle with that one. Okay, so yeah, they are your energy level diagram. So just in summary then, so you've got ice. The ice melts into liquid. We say it's endothermic because the ice will take in the energy. So therefore, because it's taking in the energy, it's using the energy to melt and change the structure. So it goes from an ice to a liquid. And then here, if you've got liquid, well, for it to freeze, it's classed as an exothermic reaction. And the energy, as it says here, the energy is transferred to the surroundings from the freezing water. Okay.